Hello, ladies and gentlemen. So today we're going to talk about the surface area and volume of cones. Okay, the cone is just a little bit different from the pyramid as it has a circular base. Okay, so we're going to need a pencil, something to write with. You're going to want to take really good notes, get those formulas down. And you're definitely going to want a calculator to plug these things into, okay? So for starters, a little bit different from other videos, we're going to start by just getting a good definition of a cone on this first slide instead of me jumping to the next. So a cone, again, it's a circular base. The curve meets at a point at the top. So again, the lateral side is more of a triangular shape, but it's not an exact triangle because now our base is circular. So there's a couple of visuals of cones here. We all know ice cream cones. My Bitmoji obviously is not the same cone that we're talking about here because it doesn't meet at a point, but again, just like a pyramid, cones meet at a point, but now their bases are going to be circular. So we're going to jump forward, we're going to use the same kind of formulas, but they're going to change now again because our bases are circular. So let's jump forward and see what that looks like. So when we're finding the surface area and volume of a cone, we got to be dealing with the right cone. So that means that the height is going to form a 90-degree angle. So you can see in this picture that the height here drops straight down to the middle of our cone. And again, we think that that's kind of on the inside of our cone. Excuse me. Okay, so the height then is forming a right angle with the base, or that circle on the bottom. So again, we still have a slant height. So that's going to go from the vertex here to the side of our circular base. And again, the regular height goes to the center of the base. So the slant height goes from the vertex to the side of the base. The regular height goes from the vertex to the center of the base. So again, the bases here are going to be circular. And we have this lateral surface. The lateral surface is just the outside of our cone. That's what we're going to be finding when we find the surface area. Okay, so just understanding these vocab words as we jump forward and start to use them and plug them into our formulas. So the pictures we're looking at here is what you would see if you would unfold a cone. So if you would take the cone, take it from 3D and change it into a two-dimensional, you'd have that circle again, and we have a somewhat of a circular, or excuse me, somewhat of a triangular lateral surface, but again, it's not exact triangle because since our base is circular, the top part of that triangle is curved. So again, this is what it looks like if we were to take it and flatten it out, but we're not going to focus so much on this as we want to just find the lateral area, the surface area, and the volume. All right, so let's try that as we jump forward. All right, so let's look at the formula and what it's going to look like for a cone. So again, you could use the formula that we found for the surface area for a pyramid, but again, all cones are going to have the same shape base. All cones are going to have a circular base. So we, instead of putting in big B and the perimeter, we can plug in what we know about the circular bases. So the area of a circular, so that big B would be pi r squared. So the perimeter would be 2 pi r. So notice what happens when I plug in perimeter. If I plug in 2 pi r for P, the 2 with the 1/2 is actually going to end up canceling. So what it's going to look like for our surface area is pi r squared plus pi rl. Because again, the 2 pi, or the 2 and the 1/2 are going to cancel each other out. So the surface area formula that I would jot down, or I would write for cones, is pi r squared plus pi rl. Again, you can use this one. This is what we get from our pyramids. But again, the base and the perimeter, they're going to be the area of a circle and the circumference of a circle every single time when we deal with cones. So instead of using big B and P, I like to write down just pi r squared and pi r right off the bat, because again, that's what we're going to be using, because every single time we're dealing with a cone, the base is a circle. Likewise, when we talk about volume, instead of using big B, we're going to use pi r squared. So you can write down that one, or you could write down pi r squared h all over 3. So whatever formula you want to write down for volume, they mean the same thing. The second one that I just jotted down, that's easier to help us type into our calculator. Again, whichever one you want to write down, they both say the same thing. So get these formulas written down. They're super important to have as we work through these problems. Again, we have to understand what pi, r, h, and l, we got to break down those variables. So r we know is going to be radius. The L, again, that's going to be that slant height. The slant height, again, goes from the point or the tip of the cone to the edge of the base, or the side of the base, the edge of the base, however you want to say that, okay? And then the h, the last variable we need to know, that's our regular height, and that goes from the point or the tip, and that goes to the center, point to center of base, okay? So again, the height is more internal. It's on the inside of the cones or the pyramids, okay? And that's kind of how you can do the difference. The slant height would be on the outside, on the sides of the cones or the pyramids, and the height goes from the center or the tip to the center of the base, which is kind of an internal idea, okay? So again, knowing those variables as we jump forward and we plug them into these formulas for finding surface area and volume. Our first example out of two, we are going to find both the surface area and the volume. I don't know why it's cutting off volume, but we want to find both. Okay, so surface area and volume. Again, I'm going to cut my screen in half so we can work with one on one side and one on the other. So the surface area formula again would be pi r squared plus pi r l. So let's find what all of those are. So r, our radius here, it looks like is going to be 5. That's given to us. And the other thing we need to find is L. And again, L is that slant height. So notice here, we're given the height of the cone, but we're not given the slant height. But again, the height with the radius and the slant height, notice that they form a triangle. So if I were to pull that outside of our picture, again, we have a right triangle. We know this side is 5 and this side is 12. We just need to find our hypotenuse. So again, you can use the Pythagorean theorem. So x squared equals 5 squared plus 12 squared. X squared equals 169. If you were to type that into your calculator, square root both sides, it looks like x is going to give us an even 13. So the slant height then, the L that we found, is going to be 13. I've found what both variables are in my equation, so now I'm just going to plug in. So the surface area equals pi, r is 5 squared, plus pi, again, r is 5, and L is 13. And I plug them in with parentheses because then I can take that equation that I just wrote out here and I can plug that directly into my calculator. So again, use the pi button, pi, parenthesis 5, parenthesis squared, plus pi button, parenthesis 5, parenthesis 13, parenthesis, and when you hit equals, you should get back the number 282.74. because we always round to 2 decimal places. And I want to give it a good label, and again, since we're finding surface area, we know it's squared. Since I have a label on it already, I can use centimeters squared to finish off that label. Okay, so that's the surface area of this first cone. Let's find the volume. So I go over here, and if I remember the volume formula, it's pi r squared h all over 3, just like a cylinder. This is the same formula for a cylinder, but we're dividing it by 3 because, again, it's 1/3 of that whole cylinder. Okay, so if I were to plug in for what I know, r, we already know is 5, square that. H, again, the H stands for the height, which goes from the tip or the point of our cone to the center of our base, which if we look over here, that height that goes from the tip to the center of our base is given to us in this example, so we already know that that's going to be 12 all over 3. So again, to type in our calculator, use the pi button, pi, parenthesis 5, parenthesis squared, parenthesis 12, parenthesis. I would hit equals after doing just the top, and then in my calculator, you could just hit divided by 3. And the number you get back after you would type all that in should be 314.16 centimeters. And again, volume should be cubed. Okay, so here's our volume. Over here's our surface area. If you have questions on how to find either or, make sure you jot those down so we can address those. Okay? All right, our last example then of cones is going to be the one that you see on the screen. So example 2, again, we're going to find surface area and volume. So let's break our screen into 2 parts so we can do both of those. I'm going to start by writing down my surface area formula. Pi r squared plus pi r l. And over here we'll do volume, which is pi r squared h all over 3. So first off, let's figure out what these variables are. R equals, notice I don't have my radius, so that's going to be x. I also don't have this height of my cone, which I'm going to need for my volume. So I'm going to make that y. But notice it does give me this angle inside this triangle that's formed with my slant height. So I'm going to have to use something in my toolbox to help me figure out x and y. So I'm going to write x and y. 15 is my hypotenuse, and this angle over here is 54. So since it's not a nice even, or it's not a 30, 60, 90 or a 45, 45, 90, it's a 54. If we think about what tools I have in my pocket to help me find sides of this triangle, hopefully your brain jumps to trig. We're going to have to use trig to find x and y. So if I were to set up x first, x is my adjacent side and I know my hypotenuse. So adjacent and hypotenuse would be cosine. Cosine of 54 would equal a over h, so it's going to be x over 15. So when I solve for that, or if I were to type that into a calculator, I would type in 15 cosine 54. And again, I'm jumping through this, making the assumption that you remember trig. If you don't remember trig, make sure you star this so you can look back in your notes to help you figure out how we're going to set up these, how I solve these. And again, like I said, I'm moving a little faster because I'm assuming that you remember. If you don't, it's okay, but look back in your notes to help you figure this out. So when you type that into your calculator, you should get back the x value of 8.82. The other one that I'm going to solve then is the y. So y, if we look at 54, is the opposite side, and 15 is still my hypotenuse. So opposite and hypotenuse uses sine. So sine of 54 equals y over 15. So again, to solve, what I would type in my calculator is 15 sine 54. And when you punch that into your calculator, you should get back the value 12.14. And again, 2 decimal places with everything when we're finding surface area and volume. So, well, how does this help me when I jump forward and I try to find the surface area? Well, we just found x and we found y. So x is actually my radius. So now that I have my x value, I can put 8.82 in here for my r. And then I need to know my slant height. And again, if I look at this picture, actually the slant height, again, it goes from the center, or it goes from the point to the edge of our cone. So that is actually given to me. We know that is going to be 15. So I'm going to change my color so it's not as confusing here as I plug in this surface area formula. So surface area equals pi. R we found to be 8.82. That needs to be squared. Plus pi. Again, r we found to be 8.82. Not squared this time, but then L is going to be 15. So again, when I use parentheses like that, when I write it down, it's easier for me to transfer it over into calculator, because then I can just plug in what I see into my calculator. So pi button, parenthesis, 8.82, parenthesis, squared, plus pi button, parenthesis, 8.82, parenthesis, left parenthesis, 15, right parenthesis. If I hit equals, the number you should get back after all of that in your calculator should be 660.02 centimeters. And again, surface area is squared. So after you plug all that in, this is the number you should get back. If you're not getting that back, make sure you jot that down where you're confused. You could try again, or I could help you when we meet. Okay? So then let's jump over, and I'm going to change my color again because we're talking about volume over here. So volume, let's plug in what we know. Pi r we found to be 8.82 squared h. Now what is h? H again is the height from the point of our cone to the center of our base, which if you look over here, that would be the variable y. And good thing we found that already. Down here, we found that to be 12.14. All of this is going to be over 3. So again, using your parentheses, you can plug that all into your calculator. So pi button, left parenthesis 8.82, right parenthesis squared, left parenthesis 12.14, right parenthesis. I would hit equals there in your calculator, so you get a number, and then hit divided by 3, and you would get back, hopefully your calculator tells you 988.97 centimeters. Volume is cubed. Hopefully that's what you're getting. If it's not what you're getting, like I said, try again. If you still don't get it, make sure you meet with me and we can get that calculator situation figured out. So I want to thank you for taking good notes. I apologize it got a little longer than I wanted it to get here. for length of the video. But like I said, thanks for sticking it out. If you have any questions, make sure you jot those down and we can get those answered. So I hope to see you so soon. I will talk to you later.